Okay, thank you very much. So, my name is Michael Puscar. I'm the founder and CEO of Oiga Technologies. Thrilled to be here today. It's going to be a great conference, and honestly, a conference that I think is going to be a little bit different than other content technology conferences that we've been to in the past. So, as Ann mentioned, I'm a data scientist, technologist. These days, I spend most of my time working with very, very large volumes of content. We help our customers to analyze that content. We deploy AI algorithms and data analytics algorithms to extract trends and patterns from the content, help customers make more informed decisions about the content that they have. So today, I want to talk to you about your content, and specifically how AI and data science is changing how we think about content. So we're at ConTech, so I assume we're all content technologists, or at least we all have a very strong interest in content. And if you've been to a content technology conference recently, it's probably touched on the topic of AI. AI, at least tangentially, it's usually when they talk about AI, they talk about it as if it's the future. It's something we're gonna, that's gonna be coming. There's usually the obligatory presentation about how AI is potentially putting too much power into the hands of machines is potential pitfall and dangerous. Also about ethics. But usually what we talk about is what's coming in the next 3 to 5 years. So say in 5 years, for example, peer review will be handled more by artificial intelligence algorithms, right? Or in 3 years, or maybe some of these machines are writing and authoring some of the content themselves. Well, I think we all know that technology doesn't really work like that. I don't think we all just go to sleep for 5 years, wake up, and then everything's changed. We are the ones who are making the change. We're the ones who are implementing this technology. And in fact, Anne sent me an email just yesterday and said that Nature is working with AI now in peer review. So the future really is now. And so we have a great panel who's going to be following up after I speak. And they're going to be giving real-world examples of some of this technology and how it's being used right now. And I really want us to think in that context. I don't want us to think about AI as something that is going to be happening in 3 to 5 years. We should all really be thinking about it as it is right now. So if there's 2 things that you can come away with from my presentation with, the first I think is I'd really like you to have a sense of urgency. If you think about how we handled content 5 years ago, 10 years ago, 15 years ago, I think if you were in the healthcare space, for example, in the late 90s, most data was being entered in paper. And if you went to your doctor's office, maybe it was being entered into a PC. And if you were a publisher, I think if you look back at scholarly publishing, if you were dealing with your archives from the 19th century, they probably weren't digital either, or if they were really bad OCR scans. And you think about where we've come to now. So 10 years ago in healthcare, the data was being entered digitally, but there was no interoperability between the data. There was no data standards. So for the last 10 years, all of us, we've worked really hard to get to where we are. Everything that we've done, we've created content workflows, we've put our data into, in some cases, XML databases or other formats. We've really focused on getting really good processes and having our data structured, and that's great. And now we've been able to do some really interesting things. So now we can slice up our content and have better outputs and create new products. We can export to, if you're a publisher, to books, journals, but you can also to EPUB and to web, and create other products, searchable databases. So we've done a lot of work to get ourselves to that. And I think we can agree that the publishers or the healthcare providers who are able to implement this technology earlier in the process, they really had a competitive advantage. They made more money. They were really ahead of the rest of their competition. Well, I guess I'm here to tell you that AI is the ultimate competitive advantage. And if you're not implementing it right now, it's not just that you'll be years behind. I would venture to say that there's some companies in 10 years that may not in fact exist if they haven't implemented some of this technology. And 5 years ago, we had queries that we would run that would take 36, 48 hours to detect fraud, for example, of our healthcare database. Now those take, with columnar databases, they take 10 seconds, 15 seconds. So everything that we've done has gotten us to this point. And I know it's cliche, but really, we're either going to be a part of shaping the future, or we're going to have to adapt to what our competitors are doing. So first is a sense of urgency, and the second really is a sense of empowerment. I guess the next thing that most people say to me when they're talking about this is, how do we implement this technology? Where do we even start? Well, there's some good news. I think a lot of you were already doing AI if you were dealing with semantic web technology. I know a lot of you have taken a lot of your content, you're classifying it, created taxonomies and ontologies, and that's great. But that software, that costs $500,000. And when those of you in the publishing sector who decided to implement MarkLogic and start using XML databases, I mean, you spent $500,000 on that, millions of dollars if you're Elsevier. So the good news about AI software, only the truth. The good news about this software is if we think about Prediction.io, Apache Spark, Google's TensorFlow, Amazon's AWS SageMaker, most of that technology is open source, so it's free, so it's out there. And so I want to empower you. We're not going to get into too much of the technical details here, but if you're a technologist, go home, load up some content, create an instance, spin it up, and start working with this technology. It's actually very well documented, and there's so many people who are working with it right now. There's more and more examples. So that's the good news. I guess the bad news is there's a catch. Something I call free with purchase. Unfortunately, though the technology itself is low cost, the data processing is expensive. And if you want to move large amounts of data, then you're going to need to scale up in the cloud. And you're going to need to spend a lot of money just on the servers that you'll need. And the expertise is not cheap either, which is good for people like me, I guess. But I mentioned over the last 10 years that just to get here, we had to do a lot of work, right? Well, because these AI algorithms, I mean, I wrote a paper on image recognition in 1996. So these algorithms actually haven't changed. We've known about how to do AI for a long time. But two things have changed. One, we've gotten our content more organized. And two, we're able to deploy massive amounts of processing power. So now's when the fun begins. I guess about 15 years ago I heard this phrase, and I think if I had to summarize what AI is in the context of content in one phrase, it would be this. It would be, we don't know what we don't know. And that phrase was uttered by a very famous American philosopher. I don't know. So. No, I'm kidding, of course. He did say that phrase. It wasn't about artificial intelligence. It was about the weapons of mass destruction that were never found. But we spent a lot of time putting our data in content into data structures, and that is important for AI. But we've created JSON schemas and XML schemas and lots of database tables with rows and columns. But the truth about AI is it doesn't really work like that. You see, data structures and databases are built to ask questions that we already know the answers to. So I want to run a report on how many patients with this type of cancer have visited my office over the last year. Well, I know how to ask that question. I know how to get the results because I built content structure to answer those questions. The thing about AI is we don't know what we don't know. And one thing that AI is really good with content, it's in finding trends where we least expect them. So we have to think a little bit out of the box here. We want interoperability. We obviously have to structure our content, but unstructured content is very good too. All right, so Andrew had his dog, and now I have my dog. I think it's obligatory. I think it's important. This is Kane. He says, my dog is a lot bigger than Andrew's dog. So Kane's a good dog. He likes treats. So just talk a little bit about reinforcement, how we learn something new. So we usually don't know what we're about to learn. The old cliche, you learn something new every day, but we don't know what we're going to learn. So I would guess today we're probably going to learn something about AI and content because we're at ConTech, but we normally don't. I'm trying to teach myself Albanian, okay? You can say, well, Michael, you know what you're going to learn. You're going to learn Albanian. Well, that's not true because I have to learn the grammar, the tones, the sentence structure. There's so many things I don't know along the way that I'm going to need to learn. So we don't know what we don't know, and this is how we learn. Now, in AI, we talk about neural networks, but practically a lot of, and when we're talking about reinforcement, we're really just talking about trial and error. So with Kane, he doesn't know what he's going to learn. He just knows he wants a treat. And in this case, I'm going to teach him how to play dead. So he needs to first lay down, then he needs to roll over, then he needs to thrust his paws out, then he needs to stick his tongue out. And every way along the way, when he does something good, he gets a treat. And that's a positive reinforcement that creates a new neural pathway. And every time he doesn't, he gets frustrated and he starts over. And so in the end, he does learn. And he didn't know what he was going to learn. He actually learned 5 things then along the way. And this is how we learn with reinforcement in AI. And I do want to just mention briefly that this is just one AI algorithm, one way of doing AI. And there's a lot of really smart people who are thinking about this and who are coming up with other ways. And there was a great article in Wired about Carl Frist. I don't know if any of you know him. I follow him pretty closely. He's a really smart guy and has to do with minimization of free energy. And I had a bunch of slides about that, but since I don't have any to do with content, we're going to skip over that. But I do encourage you to go look him up and read about him or find me, and be happy to talk to you about it. So how does this all apply to real practical instances of how we apply AI? So we're at the ConTech conference, and a lot of people have done some really hard, a lot of work to try to get this conference ready. And I think as Clive said, they planned this conference from a year ago. I was selected to speak in March or April. Well, there's an inherent paradox there. If you're going to create a conference about emerging technology or emerging trends, which I know a lot of you do, then how do you do that a year in advance, right? How do you do that? Well, okay. One thing is you could look at the papers that have been published recently and you could analyze them. You could say, okay, maybe that will help me. Well, remember we were talking about classification and those taxonomies and ontologies? Well, if you created a number of taxonomies and ontologies and you're going to classify against those, guess what? The results are going to be about topics that you already know about, so they're not going to be emerging trends. So this is a really good example of how AI can help, for example, in publishing. It can help identify trends. It can get you ahead of the curve, ahead of your competition, and it can help you really better understand your audiences. So in addition to being the founder of Oiga, I'm actually the founder also of a company that runs clinical trials, a CRO. It's based in Colombia, where I live. And we gather a lot of content. And I want you to think about the type of content that gets gathered every time you go into the doctor's office. I mean, every time you step foot in a hospital, you have your diagnosis and treatment, your drug prescriptions, pharmacy purchases, blood work, radiology, lots and lots of information, doctor's notes. That's a lot of information. And when we talk about longitudinal patient clinical history, we're talking about every time, from the time you were born until the time that you pass. All of that information is being collected about you. It's an enormous amount of information. And now it's being collected and it's structured, and there's interoperability standards, and there's storage standards. We use things like HL7 and OMOP in the healthcare side. So you have all this information. Now, we're working, for example, right now with 3 different companies in 3 different countries, in the United States, in Spain, and in Colombia, where they're taking all this information and instead of having it be stuck in silos in hospitals or in clinics, we're finding ways to load it all up into the cloud. Of course, there's some privacy issues there. You have to comply with HIPAA laws and things like that, but there's ways to do this. So I just want you to imagine a country like Colombia, which has 50 million people. And imagine every patient, from the time they're born to the time they pass, all of this information, all in one place in the cloud. What you could do with that kind of information with artificial intelligence. What would a machine learning algorithm, what can a machine learning algorithm do? Well, it could do more than I could list here. But for example, machine learning, as it turns out, is very, very good at detecting fraud. So detecting insurance fraud, fraud with doctors. It can find drug interactions that we'd never expect. It could identify, if you're running clinical trials, the best sites to run those trials, the best doctors, the investigators. In fact, my wife, who's pregnant, she was looking for a doctor, and she was looking on Google, because we went somewhere else than we normally would be to have the baby. And she said, well, this doctor looks good. He's got 4 stars on Google, and he has all these great reviews. And you read the reviews, and it's, yeah, my wait time was low, the doctors treated me well. Well, I'm pretty sure that's not how we should be evaluating doctors, right? So, but we have all this information we can. We can use AI to evaluate doctors. So if I had to summarize what you can do with artificial intelligence across any industry, really, I would say one of the most important things that can be done is to create objective, quantitative, predictive performance measures. Okay, so before we wrap up, just I promise sort of empowerment. So I try not to get too technical in this conversation. Again, if you'd like to talk about anything technical, find me. Love to have those conversations. But every cloud-based platform now has its own tools. So Google has TensorFlow. Microsoft has Microsoft Machine Learning, not very inventive with the name. Amazon has SageMaker. There's Prediction.io. But these are out there and they're available for use. And I really encourage you, if you're a technologist, to go out and start deploying these technologies now. And if you're a manager who manages technologists, to get someone on your team doing a skunk works project. Just start moving on this, because honestly, it's not the future, it's what's happening right now. Thank you.
So before we open up for questions from Michael, we're going to hear from a few other folks that are standing before you. I will let them, or sitting, I should say. I'll let them introduce themselves. But the theme that I would like you to think about is when thinking about what Andrew put up before, his far, for you, left side was all about data and input, really, about gathering information, capturing information. And I don't want us, as we go through a day thinking a lot about AI and what it can do and how it works, to forget that really important foundational block, which is data and data science. And personally thinking about, when does a model become an AI? Where is that line? And quite frankly, from a business perspective, does it matter? And the other thing I'd like you to think about, as our panelists introduce themselves and tell you a bit about what they're doing in their day lives, is just thinking about what are the business applications? What are the real things you need to accomplish? Again, to parrot Andrew a little bit, and probably because he conveniently said things I believe in, you shouldn't be looking for how can I use AI. You should be looking and understanding what are your business challenges, what are your organizational challenges, and what are the tools and technologies and systems available to help me address those challenges in the most effective way. And at that point, you may find that data science, and all of the various things under the umbrella of AI have a place in addressing your opportunities and your problems. We're going to start with Michael Head and go through, and you'll hear some interesting things that folks are doing with data and with AI.
Thank you, Anne. Good morning, everyone. My name is Dr. Michael Head. I am a Senior Research Fellow at the University of Southampton. I was here at ConTech last year, shouting about life as an academic, and for some reason I've been invited back again this year, so thank you to whoever got fooled into that decision. I'm based in a clinical informatics research unit, and my background is looking at how money is spent in research. Infectious diseases is my main area of interest. So we're putting together a large data set, or large by academic standards, not by some of your standards, of about 80,000 projects awarded related to infectious diseases. That's covering the G20 country funders, which is where most of the world's money comes from, over a 18-year time period from 2000 up to the present day. And we are describing each study by the type of science, if it's a laboratory study or a clinical trial, by the disease it covers, and also by the geographical focus of the research. So we will have some quite granular data. We'll be able to point at certain areas and consider them well-funded or not well-funded. With this data, there are lots of now other large open data sets in global health. For example, looking at the burden of disease, how many cases and how many deaths there are in certain diseases. So we can look at the amount of money going into research into HIV, tuberculosis, malaria, and pneumonia, and compare that with the number of deaths in those diseases to get an idea roughly of how well we're spending our money. At the moment, there's billions upon billions of dollars spent every year on health research, and no one really knows how or where it's spent or what good it's actually doing. We are somewhat behind the curve on this. The other project in our unit is a large NHS database called Edge, which hosts about 100,000 projects that are going on in the NHS or have completed in the NHS. And that's a real-time research management tool. So, for example, if a nurse is recruiting a patient into a breast cancer trial in Southampton Hospital, once she uploads the data, I could, in theory, come here, click refresh on the computer screen, and it would increase the number of patients in that trial by 1. So it's to use and monitor research and to look at the impact of research as well. So that's a kind of main focus in our unit. I'm certainly not an artificial intelligence expert at all. I'm a data scientist, and I think academia, for all its laudable attributes, is somewhat behind the curve when it comes to data science and things like AI. Michael in his talk put up a slide that's headed a sense of urgency, and I had to smile at that because academia is anything but a sense of urgency. In things like a pandemic flu or Ebola outbreak, you have Oxfam and Red Cross and Medicines Sans Frontières rushing to the front line to set up their clinics, whereas us academics are having a coffee in the kitchen thinking, maybe we could do some research about this. Who will fund it? And in terms of informatics and those sorts of areas, we're starting to get a hang of using data, but it's only really been the last perhaps 5 years or so that this is starting to be taken seriously. And there are very, very large data sets out there that we can use, particularly in sort of some of the health aspects that Michael touched on. In the UK, we're pretty good at primary care data, which is GP data, basically. There's large and well-established, really good data sets on that. Hospital data is a bit more of a nightmare. And I think there's large opportunities just to streamline and improve and standardise that data to make it more research ready, to be able to pick out some of the aspects that Michael raised in his talk. I think also the global health data, so if you want to find out cases or deaths of a disease in Chad or Central African Republic, the data sets will be really, really thin. There are databases out there that model the data and make guesses, but that's literally what they are guesses. And on this, policy decisions by the World Health Organization and all those other big organizations, they're based on that really, really poor data. So I think collecting good data in the first place, apologies for coming in late on Andrew's talk, but I think he kind of referred to the kind of, well, put rubbish in, get rubbish out type phenomenon, which in some aspects of global health is what we're doing. So I think if we can get the better data and put it in our algorithms, in our models, then we will have some really, really helpful findings that can improve the allocation of health resources. The amount of money and resource that any country, particularly in the poorer parts of the world, have to dedicate to health infrastructure, to dole out vaccine programs, to build a hospital, things like that, it's very, very limited. So I think better, larger collections of data can help inform how best to allocate those limited resources. A couple of other brief points that were raised already as well. The public engagement aspect, I think, is crucial for AI. I've seen so many aspects in different areas of health where the public engagement and the public consultation have been thin, if not present. Vaccines is a particular area of interest of mine, including the activities of anti-vaccination activists. And so many vaccine programs have been scuppered by what are essentially lies and misinformation coming out of the vaccine community. And they could have been quelled a little more easily if there'd been better public engagement when the vaccine was released. So the human papillomavirus vaccine, HPV, is one particular example there. Also in the aspect of getting students looking at AI and related skills early. Certainly in the UK we have something called STEM ambassadors. If you don't know what that is, it's probably worth looking up. They are a big group who run activities, or they direct you towards activities in schools and at careers fairs and things like that. I am a STEM ambassador and I've done quite a few activities on it, and it's quite good fun going to chat to school kids about what you do. They also run code clubs as well, which might be an opportunity. They're often run in the local libraries. So again, there may be opportunities to engage the future generations in the sorts of areas that we collectively work on here. I think that is all I will say at this point. So yeah, plenty of opportunities in health, but certainly in academia we have not grasped them fully as yet. I will now move on.
I'm just going to do a pick up on Code Club because my partner manages all of the volunteering for Code Club in London and the east of England. So if you want to volunteer for primary school kids at Code Club, Yeah, please do. It's fantastic. Particularly if you've got daughters, because already at that early age, he finds that it's still sort of boys dominate those after-school clubs, even at primary school age. Anyway, enough of Dan. Back to me. My name's Martha Sedgwick, and I run the product innovation group at Sage Publishing, and we talk about what we do as building bridges to knowledge in a world where technology is changing not only the ways we can deliver products and engage with our audiences, but also the way that research is being done. And for us in particular, our sort of area of interest is in sort of social science research and changes that are happening there. So I sort of wanted to touch a little bit on what we're doing in terms of sort of products, but also what we're doing in terms of engaging with that sort of research community as part of this intro. My group's been responsible for shepherding the delivery of all of our new product development over the last decade at Sage, and we've brought out a large number of new, largely content-driven products, including online video collections, statistical databases, primary source archives, case study collections, and more. One of the sort of going back to that sort of leading with the problem and responding with the technology, one of the challenges we've sort of really been trying to work through how we address over the last few years with this range of different social science content types that we now have available is how we best support the sort of discovery and use of that content. And we've invested quite heavily in a content enrichment program so that we run all of that social science content through natural language processing to create relationships and build a recommendation engine that we can then sort of deliver to end users to link a journal article, someone reading a journal article out to relevant similar material that's going to be of use to them, whether that might be video content, case studies, or others. And it's been a really sort of a huge effort, a fantastic project. I think particularly challenging in social sciences, where you get terms that are much more sort of squishy, as Alan says. And Alan Maloney has been the guy really driving this at Sage, and he's going to be talking about that project a bit more tomorrow afternoon. So plug for his talk. Another area where sort of machine learning technologies has really sort of transformed the use of our products in the last couple of years has been in the digital archive publishing that we do through our Adam Matthew company. And then we've partnered with an external organisation to enable to enable search of handwritten text. And this is sort of transformational for historians working with primary source archives that are all handwritten. So the machine now can read and sort of guesstimate that what the words are, based on co-location of characters. The more data you put in, the better the machine gets, and it's really sort of phenomenal now what that technology has enabled across those primary source archives, and well worth having a look at that. The other areas of sort of thinking about sort of AI and how we better enable discovery and use of our content at Sage have been sort of more experimental still. We have an innovation lab in-house, and you can read on our Sage Labs website some more of the experiments. But we've been doing some work looking at chatbots, and I'm sure Alice is going to talk about some much more impressive use of those in a minute. But we've been looking at how we can support study skills and student learning, sort of presentation skills, feeding some of our content into chatbot interfaces, using some of the open source applications out there, and experimenting with what might be possible to create more interactive, sort of dialogue-driven products. And also doing some work on image recognition. Sort of accessibility is a big priority. Accessibility of our content and our products is a big priority for us at the moment. And actually applying tags to images throughout our journal corpus can be sort of done so much more cheaply now with some of the technologies, the image recognition technologies available. And we've been doing some really interesting experiments looking at that too. So more, as I said, on the sort of Sage Labs website, just a sort of flavour of some of that experimentation, looking at how these emerging technologies might apply to sort of add value to our products and our business and the engagement with our content. But I also wanted to touch on the initiative that we have set up in the last couple of years at Sage called Sage Ocean, and this is a response to what we're seeing as a really exciting sort of transformation in social science research. And this is seeing very early stages social scientists now beginning to engage with big data and new technologies as they try and understand the world around us. There's huge, vast data sets now available, of course, social media being one source, but many other areas. And I think important for social scientists to have a seat at the table alongside big tech, actually using that data to understand our world for social good. But I think as sort of Michael was referring to earlier, sort of huge challenges facing social science researchers as well in this space, not least access to data in the first place, but also the skills needed to analyze these data. You need data science skills, and social scientists, traditionally, we struggle with stats education and quant skills in the UK, let alone sort of data science skills. And so we're doing some work to look at how we can advocate, but also build products to support the development of data science skills for social scientists, and also exploring what's new software is needed to analyze data at scale. We'll be announcing a first investment in a sort of startup developing this sort of software next week. So I can't talk about it today. Along with all of this, of course, come sort of ethical questions and challenges that we need to tackle, and the social science community needs to tackle sort of head on. An important part of the dialogue and the discussion around this area. But yeah, that's hopefully give you a bit more of a flavour of some of the things that we've been looking at Sage.
Hello, everybody. My name is Alice, and I work on the business development team for the Google Assistant. So I really come from a very different perspective on this stage, separately from all of the data processing and very advanced experiments going on at my company in order to build consumer AI. We also have to make decisions on what types of user experiences we want AI to drive in the very everyday space. So Google's mission is to organize the world's information and make it universally accessible and useful. So when we think about accessibility, voice-driven interfaces is great. I think we can expect a lot of exciting things to happen when we think about the next billion users and their ability to get things done in natural language, which previously would have required a lot of technology literacy, from accessing financial services to basic information around them or transportation options, things like this. Accessibility, I think, is really an exciting trend in making technology cheaper for everybody. And then, of course, utility, actually making things useful. So what can you get done just by asking today that previously would have required a very complex set of operations, like logging in and scrolling and clicking through menus. And just user experience is about to undergo a massive overhaul for any sort of consumer journey. So a big part of my job is talking to companies here in the UK to learn about what type of disruption would be helpful for consumers and helpful for businesses and content creators. What type of content consumption do users want, given their new needs, new cultural needs of 2018 and beyond, which often means there's a grand need for a little bit of mental calmness. We're completely overwhelmed, I think, as consumers. So how do we cut through some of the noise? Also raises questions on, well, in things like voice-activated interfaces, is it easy to maintain open principles as well? Principles of openness, such as the principles of the open web, or are there new threats of, spammy content that could come in? So how do we defend against those as we build new platforms? So yeah, we're just at the very, very beginning of figuring out what kind of basic consumer interfaces should look like, powered by a lot of the data science tools behind natural language processing and beyond. So yep, some of the stuff on my mind.
I think this is our mic. I'm not sure, is there a mic for the audience questions, or if not, we'll just have to ask you to stand up and project. So I'm going to ask the folks here the first question, and then hopefully by then you'll have your thoughts together and you'll have some questions. If not, I've got a whole list. So One of the things I think that's common to everything that each of you have spoken about is the idea of looking at data and the various ways in which it would be manipulated and incorporated into products and services, looking at that data as an asset. And so what I'd like to hear from you is, how does your organization treat data as an asset, in so much as how you invest in data or in the skills and processes and practices or tools that exist around it? We'll start with Michael.
Okay.
Then we'll come back to Michael.
So in terms of investing in data, so certainly, not my institution specifically, but sort of the global health world, the funders and the World Health Organization and organizations like that, they are starting to move towards this platform. There are now funding streams focused on digital science and health informatics and that sort of thing. And I think sort of the case has been made that investing in health data is important to reduce health burdens, in particularly in poor parts of the world. There's a little mantra that goes around that says, if you invest in health, you invest in wealth.
What does it mean to invest in health data?
What does it mean to invest in health data? Any particular context? Or
That you processes put in place to capture data? Is it people manipulating that data? Is it expanding the amount of data that you have, or categorizing it differently?
Well, yeah, it is all of those things. Putting the infrastructure in place to collect the data. Diagnosing diseases in a rural hut in Eritrea is a tricky thing. So providing training for the people at the very sort of start of that data capture pathway to put the data in correctly. So diagnosing the disease correctly is one thing. And then getting it through that pathway to, for example, the Ministries of Health, and then they upload it to a platform somewhere. Translating it from paper into a computer form is, again, something that's absent in many parts of the world. And then eventually, some years later probably, it'll come down to someone like me in the university. And actually one of my ambitions is to quicken the process by which knowledge coming from research is useful in policy and practice. So getting the numbers and the data out of research projects as they happen, rather than waiting for it to be published in a paper, maybe years later, and then the policymaker in the Ministry of Health in Eritrea will look at it years after that. You're looking at data that is maybe a decade old and might not be remotely relevant to the current situation. So the investment needs to be at all sections of the pathway, but we do, for example, need to go back to that rural hut in Eritrea and give that person training to diagnose their burden of disease more accurately than they are able to at the moment, is kind of one thought, perhaps.
In terms of data as an asset for powering voice technologies, this is an enormous topic, but I'll just use one very tangible example. So we definitely are building our data sets to help inform speech recognition. So with voices that have very different accents, especially in the UK, there's a massive diversity of accents. So I know that, we're really focused on getting as much data as we can for people that have different accents so that we can be better at recognizing how people sound. And so that'll get smarter and smarter over time.
So yeah, we should invest lots in data. It's really critical for sort of understanding our business and sort of driving business insight, driving decisions. It's really important, I think, to invest in sort of data literate workforce so that people are thinking in the right ways and asking different questions and knowing how to handle the data when we have it. And I'd say the reality probably at Sage is a mixed picture. And I could imagine that may be similar at sort of other publishing organizations too. Our content is in a fantastic state actually in terms of the sort of storage, the structure, the sort of metadata associated information about our sort of researchers, user behavior, our customers is in, other, sort of siloed, and I think there's work to be done, projects underway to sort of bring that together better to help us understand. We just sort of started bringing data scientists into our editorial group, so we have new sort of skills coming into the organisation at that level. But and I think sort of more to be done to build the data pipes alongside the skills.
Yeah, I'll just add that I would say that the most important investment that anyone can make is in interoperability. I think you can never have too much content. You can never have too much data, so you want to gather as much as you can. But oftentimes that means you'll have image data, you'll have data from a variety of different sources. They're all in different formats. So that mapping that brings them together is what makes the data analytics possible, and it's what is going to make the AI algorithm, it's going to power the AI algorithm. So the content and data interoperability is really paramount.
I saw a hand.
Yeah, I'll shout, if that's all right. It'll take forever. So really interesting, Dr. Head's comments around needing to get data out quicker to inform policy to drive change, and also explaining the slowness of the publishing cycle. Also linking to the point about interoperability and about getting massive amounts of open data sets. It's really interesting talking about this because it feels like the publishing business and cycle is getting in the way of all this progress and vision that all this AI and data can achieve. So are we going to start talking about how we can make the publishing process faster and better and more open so that we can enable all these great next billion connectivity and big social change and interoperability instead of big walls and islands that aren't connected together?
Martha, you want to talk to that one?
Just as the only publisher sitting here.
Maybe there's some other publishers in the audience who'd like to respond as well. But yeah, I mean, I think there's sort of huge opportunities to look at how we can use sort of some of these technologies to speed up the publishing process, to take out some of the schlep work and automate sort of what can be sort of automated and augment sort of the human work involved that will still be sort of necessary in the publishing process. So all of that is true. I think the sort of the slowness of the publishing cycle is, as you say, I think there's also a sort of link into the slowness of academia that Michael was also talking about. And so we've got sort of whole ecosystem here that is sort of challenged and good to be challenged to sort of see how we can evolve it.
I'm curious, Alice, from your perspective too, as a non-publishing environment, can you move that much faster?
You mean
Just to address
technology?
I'm sorry, what was your first name?
Yeah, Tommy.
Addressing Tom's question. So you say that it seems as though the publishing process slows things down. What about Google? It seems like you might be able to be nimble.
Well, we're both nimble and slow. I think it's always critical if you're in an innovation org or in an organization where innovation is valuable to take a fraction of your operation and make it agile. So if you can't make your entire operation as chaotic as is required to do iterative prototyping and design thinking and all of these things, then separate out a little segment to really experiment and play. So when we talk to big companies that they're saying, oh, we need to shift the entire UX to voice, we say, not so fast. Our systems aren't that smart yet. We still have to figure out what works. We have to learn together. The best and cheapest and most responsible way of doing this is not trying to move your entire system first. So I think just testing cheaply, quickly, and learning from it, and then learning quickly, and then scaling that knowledge quickly and effectively across the entire big company will inform the next steps that you need to take. And sometimes the first steps don't need to be running. I think that this is one of the big lessons that we're learning on the Google Assistant as well, is a lot of times we say, we're so behind, there are other systems that have been out there for longer. Yikes, it's a new world, it's highly competitive. But we're realizing we actually do need to make responsible decisions to make sure in 2 years we don't have to scrap all the back end and rebuild it. So I think a lot of listening and learning quickly and learning separately is helpful.
Either of you have anything that you'd like to add?
I suppose I can just quickly add to what Martha said. Certainly, in terms of the slowness of getting information out there to who it's needed to, the publishing cycle is very slow, but it is just one factor, and academia is part of that. If anybody saw my talk last year, you'll heard me moan incessantly about the need to publish in high-impact journals. So what I might do is take my manuscript, send it to the Lancet. The Lancet doesn't fancy it, so it rejects it. That takes a few weeks. My faculty would then like me to publish it in a nearly as high-impact journal, so send it to the second on the list. They reject it, so faculty then wants me to put it in the next high-impact journal. So it might take a few months to get a paper submitted and for them to review it. So it might be a year after submission, just because of the fact I've gone through so many journals to try and promote my own academic career and please my university. So that is, again, just one additional factor that slows things down. I think that academia can itself be do this a lot more smartly. And I did have another point then, but it's gone completely out of my mind. Oh, so preprint servers, which is something that journals are now starting to approve of. There are now basically databases out there where you can shove kind of your first version paper online, make it openly available. Previously, journals didn't like this. They wanted to have the first dibs on your paper. But now most journals I've seen, I think certainly Sage do as well, will allow you to put a paper on a preprint server. You can then send it to all the policymakers and stakeholders that you wish, while submitting it to a journal as well. So your information is out there a bit quicker. So that is one example of how we're getting better at things, but sure, everything is still far too slow from funding the research to making it impactful.
Yeah, I just want to add something really quickly. I think sometimes we think that we're moving slowly, but as I mentioned, the progress that's been made over the last 10 years is fascinating. And you know, Taylor and Francis and peer review, they're implementing this new blockchain prototype, which is amazing. And we talked about Nature, who is going to be introducing AI into the peer review process as well.
It was on Silo, the product that does.
Yeah. So I mean, I think people are innovating, and I think so. What's going to help make things move faster is the competition. I think when there's a lot of competition, I think it sort of provides some momentum to let's go ahead and start doing something.
So I have one question for you all, just thinking about this. So we're talking about moving faster. We're talking about getting lots of data. And I was recently in China. I was there as part of a graduate program I'm taking part in data science and business analytics. And so we had people come in, major organizations in China, telling us about what they're doing with data. And what struck me in a lot of my cohort was that these organizations were really not as encumbered by privacy issues and by data management types of issues. Certainly not as much as like GDPR or even in the US that we are. So what I am curious about is what your perspectives are about the balance between our ability to move forward, move quickly, as Tommy was saying, and also balance out privacy concerns and things that might exist within the areas that we're working. Yeah. Anyone?
I'll just start and say, yeah, it's an enormous issue, and but the good news is on the healthcare side, like the Amazon servers now, they have HIPAA compliant servers. So it's something that is being considered, and it needs to be considered at every step along the way. It's really paramount importance.
I think a few years back we had a bit of a sort of saga with patient healthcare data. There were efforts to sort of link data across hospitals and GP surgeries and that sort of thing, and use it for research data. There was very little public consultation with it, and there was also talk about insurance companies getting hold of the data to cost your life insurance. The papers had a field day with that, and public confidence was significantly knocked with it, and certainly sort of measures to improve the linkage of patient data has been scaled back. People are very, very sensitive about their healthcare data. So I'm actually going to ask Michael a question, if you don't mind. How is kind of the Amazon being integrated into the health field sort of being taken by the American public? So I think over here, having Amazon or indeed Google or any other company like that in charge of your healthcare data would make people very nervous. How are the Americans taking it?
Well, actually, I live in Colombia. I live in Latin America, but I can tell you that in some ways Americans are almost used to not having their content their data be private, unfortunately. But it is a concern that. Do you want to add something in?
Actually, so I mean, there's a well-documented privacy paradox, and it certainly is at play in the United States. And anybody else from the U.S., please chime in. Which is, there's a lot of legitimate angst about data and data usage, but by the same token, every time we want a convenience, we're willing to very quickly give up our data to get what we want. And there are, academic studies about the privacy paradox. So I find that people don't always act the way they say they will act. And this applies to healthcare too, because when I'm in a healthcare workflow and I want something to be easier for me, I'm willing to sign over the rights that I need to sign over. And I think that I'm not uncommon as an American.
I was in China a few weeks ago too, and but I didn't see you. Yeah. But yeah, I was so struck by just the different stance on data privacy, and just the sort of, it's a different world where there's a sort of expectation of a level of surveillance, and just that's the way it is. That is just completely different here. And all the things that you can read about around sort of social credit now being applied to people based on how they behave in society is sort of, yeah. Yeah. I know it's a different world. I was speaking to a really interested, a really fascinating sort of research group out there who've just been commissioned by Baidu to do some work for them. Baidu, the sort of big search engine in China, of course, and it's the first time that they've worked with social scientists, and the group are commissioned to look at to help them understand the social impact of their technology, and this has come after a number of big scandals for Baidu last year. One of which was sort of unbelievable, but was that the business model promoting sort of advertising is so integrated into the search results that you cannot distinguish what's an advert and what's a real result. And as a result, people would be doing a search for the nearest hospital, A&E emergency, and getting sort of not very good hospitals and sort of surgeries at the top of the results ranking, and the good ones pushed down by the advertising, and people ended up dying, from this sort of thing. So, number of different scandals has resulted in them thinking actually it's not just about the tech people and the data scientists fixing things, solving problems, selling adverts, but also we need to be thinking about the social impact of the technology that we're building and bring that into the fold. So exciting that they're starting to do that now, but a big sort of reminder about the sort of importance of ethics and how these systems are being designed.
Yeah, I think as an industry overall, we need to be better at showing what great looks like with regards to being transparent with our users. And I definitely can't speak to data privacy on behalf of my company, but I just think in general, users will probably be happy to, elect certain conveniences, but we need to make it, there's a lot of design decisions we can make that would be dramatically better than what we have today across websites. From the cookie pop-up to the tiny little terms of service at the bottom as you opt into things. I think there's ways we can breed trust just with better design of how we have users opt in. And I think that trust is eroding across the industry, and that's something that we have a responsibility to fix.
More questions from the audience? I think we have time for one more. Two more then. So, right here.
For the AI, usually we say we need good data, and but the question is, good data and real data. How would you describe what is good data for AI?
I can tell you something from the classes I've been taking, which is very interesting. So the very first class, data science, the very first time I sat down in the classroom, the first thing the professor said was, quoted George Box, and he said, all models are wrong, but some are useful. And I think that with data, the interesting thing about good data, it really depends on what your issue is. And I don't think I don't think people realize the effort that it takes to, as Michael was saying, to make data interoperable, to make it meaningful, to assess what you have, and to understand, well, what questions can this data answer and what questions can't the data answer? And for the particular question or issue I have, do I have the right information? And where I don't, can I make assumptions? Can I make adjustments? Can I do something to my model to make it closer to emulating reality without making it fiction, complete fiction? If we have time, Dan, you could even talk about some of the stuff that you've been doing, I know, with data and just how that works. But anyone want to take it from there?
I'm just going to go off and go out on a limb and just say there really is no bad data, especially if you're doing reinforcement with AI, because you get that data processed, and when it makes a mistake, it gets negative reinforcement, and then that sort of decision gets discarded. So I've always been in our work, just say get as much data as you can from every resource that you can. I think there's actually a group here at ConTech who has a software that's analyzing fake news, for example, and that's some very subjective decisions being made there, and it all comes down to the reinforcement that the machine is getting. Anybody want to add anything?
I suppose just very quickly. So the subjective decision making. If any health body is deciding to put more money into a vaccine program or more money into the emergency department or whatever, it is basically a bunch of clever people sat around the table going, I think we should do that. So to best inform their decision making, you need good data. The data needs to be reflective of the problem, which is still a kind of subjective thing, but that makes it good data. That there is a lot of pneumonia and not so much malaria in this part of Africa. The precise numbers you have will be wrong, actually. If you say there's 1 million deaths in pneumonia, it's probably 950,000 or 1.2 million. It doesn't really matter, that's still a lot. So as long as it's in the right ballpark, I would say that is good enough data. But obviously it's a difficult thing to define precisely.
Sampling, and there are other techniques that you can do. And I think Andrew's back before when he showed up all his faces, and 85% were white men and 15 or 11% were white women. You know, obviously that's not good data depending on the problem. We do have one more question in the back, and I think we started a little late, so we'll...
Hi, my name is Ali Shah. I'm head of BD for Benchside, the Google-backed AI life science R&D platform. So what we've been doing is enabling life science research through creating this great tool. And I guess my question, you're talking about kind of voice and the user experience and how things are moving forward. How do you get a user base that's in the life sciences not very engaged to new process, new types of engagement in terms of what they're seeing? How do you kind of engage those people into kind of engaging a new platform?
We're trying to figure that out as well. No, really, I think it starts with a good use case that helps people's lives be more simple via the solution you're proposing. If you're providing something that feels refreshing rather than confusing or pointless, it's probably going to win in the end. And then you just need to play the discovery game of how to educate people on how to use the new platforms. It's a really challenging one.
Actually, I want to add to that, just because one of the things that I've seen through our consulting practice, and I'm sure many of you have seen here, is that people get comfortable with things as consumers, and then you can start to introduce those things to them as professionals. So I would almost look for a base where the consumers are acting in a way and try to find your professional, extract people that might be of the profession you're interested in from that group and try to use them as your seeds, try to get started. But, consumer has been really setting the bar for professional interactions now for probably a decade. I think we're out of time, but thank you all very much. I'd like to thank our panel, please.